Hello, everyone. This is Sanjay Srivastava. I'm the founder and CEO of Vocareum. Thanks for joining us. Today, we have David Lynn, who runs our business development, and the main speaker today, which is Dr. David Joyner from Georgia Tech. So here's the agenda. I will start with a 10-minute introduction of Vocareum. So hopefully, just give you an idea if you're not familiar with Vocareum at all. And then after that, I'll hand it over to Dr. Joyner to talk about his experience, and then we'll open it for Q&A. So in the middle of the presentation, if you want to ask any questions, you can ask it on chat, and hopefully David or I will be able to respond to it. And otherwise, at the end of it, we'll open up the mics. So just really quickly about Vocareum, our mission is to provide virtual labs and assessment, security and budget and at scale. And what we mean by virtual labs, these are environments which have full compute and data which a teacher can assign to a student, and also put constraints around it. For example, you can use this lab between this and this time, as well as put assessment strategies. And hopefully you will hear a lot more about assessment strategies. So today we are used by about 600,000 active students at any given time. There are more than 600 universities in US alone that are using our product. Here are some of the subjects that are taught in Vocareum. These are data science, programming, big data, machine learning, databases, full stack, engineering, cloud computing, some DevOps, and cybersecurity. I mean, I would say the three most popular topics on Vocareum right now are data science, programming, and cloud computing. But we are seeing quite a bit of everything else. For example, people coming to us for machine learning for say GPU or TensorFlow or big data because they don't want to set their own Hadoop cluster, but still they want the learners to use it. And over time, we have learned from our teachers like Dr. Joyner, and we have implemented a pretty sophisticated set of assessment capabilities. There's a lot of automated grading capabilities, and hopefully you'll hear more about it. There are manual grading. So for example, if you're running a class of 1,000 students and you have 60 undergrad graders, then we can sort of manage all that for you. You can provide some in-context feedback to the learners. Competition and leaderboard, this is becoming pretty interesting, especially for machine learning. So if you go to our website, you'll see some case studies from Cornell. So what sometimes teachers are doing that you give students a set of data sets to work on. And then when they submit it, their algorithm is evaluated against hidden data sets, and then they are placed in a leaderboard. And it is actually pretty fascinating when it has been implemented. And then we have mastery learning and peer reviews. And the platform is flexible enough that you can, for the same assignment, you can mix and match different assessment strategies. So how do we deliver all these different diverse set of labs from programming to cybersecurity and Hadoop? So underlying, we have a pretty diverse IT infrastructure. So we might be implementing something as a Docker containers or virtual machines, or even give you a cloud account. And we use that to develop these class of applications. So for example, web applications, these are things like Jupyter Notebook and RStudio will deliver. Streaming Linux applications. So for example, you might need MySQL Workbench or Rattle for RStudio or Eclipse will deliver that. We'll deliver batch compute clusters. So we do that for grading, but also for things like Hadoop, for Spark. Cloud infrastructure, this is a very large deployment on our platform, thanks to our partnership with AWS, where we will deliver a cloud account to a learner, and these cloud accounts are secured by policies and budgets and things like that, so the students can work in a safe and secure environment. And these are the applications that we manage it ourselves, which means we will worry about the operating system upgrades and the package installation and tools. But if you need to bring your own application, then there are few virtualization technologies that we use that you can deploy it fairly quickly. So you can bring, for example, your Docker images, you can bring your virtual machine images, or even if you want to deploy you can build your own AppStream image. For those who might not be familiar with it, AppStream is an AWS technology which we use to deliver Windows applications. So once again, this is a list of our web applications and frameworks, which is Jupyter Notebook, RStudio, terminals, different databases, MySQL, Mongo, Neo4j, and Postgres are natively supported. These days, Neo4j is becoming pretty popular. Hadoop applications talked about it, machine learning frameworks, and then some IDEs like Eclipse, Node, Cloud9, Node, and lots of different compilers and tools for different languages like Go, Scala, R, and Java, Python. Here are, once again, these are the desktop applications which are not natively supported: MySQL, Workbench, Eclipse, Rattle, Spider, Firefox browser, pgadmin, and and we are continuously adding to the list. We do believe that the labs do not exist in isolation, so we have invested a fair amount of effort to making sure these labs are as open as possible. And one aspect dimension of this has been making sure that they integrate well with your learning management systems like Canvas or edX or Blackboard, Moodle, Sakai. After the whole sort of the COVID crisis, one of the biggest thing which happened in Vocareum immediately is we started doing more and more exams on Vocareum because students could not go to their exam centers. So the exams mean sometimes they're synchronous exam with 500 students. You can go to our website and see a case study from Singapore University, SUTD, where they do that. Or that was, of course, before this case study is from before COVID. Asynchronous exams, which one of the examples is like you'll open the exam for 2 days and the platform will make sure that the students, say, for example, have 90 minutes to finish the exams. Something else which we delivered is a scheduled Proctored certification test. This is for one of our corporate customers. So the student can go there and sign up for, say, a 90-minute exam. And then we have an integration to a proctoring service, in this case, PSI, where everything from that point onwards will happen automatically. You can deliver things like random tests from a bank of problems, or there's some built-in plagiarism detection, which is becoming more and more important. Once again, the point I would like to make is that we do believe that we don't have the IDE which can be used for doing everything. So we try to be fairly agnostic. While Vocareum we have as our own IDE, but we'll drop the student in a Jupyter Notebook or a RStudio or a Cloud9 or Eclipse. And this is something which we're trying to stay as up to date as possible, so that when your learners leave, they have actually experience with the same tool that they'll be using in their professional environment. Another sort of aspect about Vocareum, we did build it so that it can be used for not only advanced coursework, but research. For example, we just announced our support for a hackathon for COVID with NIH and Stanford and AWS. So for example, you can run long-running jobs. So the record we have seen is a machine learning class from Columbia where they run the grading job for 48 hours. You can bring large data sets, which means, again, the largest we have seen is a 0.5 terabyte data set brought to Vocareum to deliver to the students. And also a lot of times when you're working with an environment, you can't just work with one tool. Sometimes you might need, say, a Jupyter Notebook with a cloud environment in the database. And we'll build an environment where we will bring all these different tools together in a single environment, and it will have the same management infrastructure around it. It is deployed in lots of different learning contexts: MOOCs and hands-on labs, skill-based exam, boot camps, research, to distribute content, syndicated content, and for virtual campus labs. This is just to make the point that we can deliver an enterprise-grade security, which means for your organization, all the compute and storage can be completely isolated in its own virtual private network. This is sometimes important if you're running a machine learning university in a company where you want to bring a proprietary data set as a part of the whole learning infrastructure. So we have the infrastructure to deliver that. as I was saying, that we intend it to be fairly open, and one of the aspect of it is to have a pretty sophisticated REST API, which we can use for SSO and analytics and to create content. Maybe you're storing your content in GitHub and you want to make sure that you update Vocareum content from there. So there is actually a pretty sophisticated and rich set of API, and we're continuously adding to it. So this is not Q&A. At this point, I would like to hand it to Dr. Joyner. I had an intro written for him. Unfortunately, I don't have it in front of me, so I will let David introduce himself and hopefully tell about his experience. So,
yeah, absolutely. Everyone hear me?
Yeah, David, we can hear you.
Awesome. So hi, I'm David Joyner, and I should now ask, now that it's moved to somewhere else. There. And I assume you can see my screen?
Yes.
Perfect. So hi, everybody. My name is David Joyner. I am the Executive Director of Online Education and OMSCS, which stands for Online Master of Science in Computer Science at Georgia Tech's College of Computing. Most of what I'm going to talk about today has nothing to do with that. I also, a few years ago, developed our online CS1 class with some interesting kind of design ideas behind it. And so I'm going to present just kind of what went into that, what we created. It's kind of it's non-traditional in a lot of ways, but it's something I think I encourage people to consider some of the ways that we designed that, because I think it has some valuable contributions for other courses. Let me just get the chat visible just so if questions come in. If you have any questions for me as we go along, I'm happy to stop, so feel free to drop them in the chat. I've got a monitor that just has the chat window up, assuming it doesn't disappear again. So, so our goal was to scale up the availability of intro-level computer science education. And so the way we decided to do that was to develop an online version of CS 1301, Introduction to Computing in Python. We wanted to develop it so that it was available as both a massive open online course and as a 4-credit offering. We observed that most MOOCs out there at the time were great outreach opportunities, but the assessment and the instruction in them was not the same as it was on campus. And what we wanted to see was if we could build a MOOC that was pretty much congruent to what we did on campus, to the point where we would trust it as a representation of what students understood. So we developed it and launched it as both a Georgia Tech course taken by on-campus students, but they take it online for credit, as well as a massive online course. So the course existed, CS1301 existed prior to my creating this version of it, developed by our excellent faculty in our Division of Computing Instruction. My experience has been teaching in our online master's program, and in this case, since I had familiarity with computing but had expertise in teaching online, they let me take a crack at developing this. The course is comprised of a number of different interlocking parts. As with most online courses, it's made of about 500 course videos, averaging length about 4 or 5 minutes. There are integrated exercises between the videos, as well as programming exercises. There is an adaptive textbook generated with McGraw-Hill. There are problem sets embedded within the course material. We have proctored exams, and there are recitations and TAs for our on-campus students. There are a lot of opportunities for interaction within the course. We integrate about 500 of those multiple choice and text entry exercises throughout the course material. This says 200 integrated programming exercises. No, it's still 200 actually. And we're up to about 250 programming problems on our problem sets and things like that. The blue boxes here actually indicate also the things that Vocareum is used for throughout this course. So I'll talk about the way it integrates into these various different components as we go along. The course exists in 4 versions. The free MOOC, which is available for anyone to go sign up for right now, there'll be a link right later if you want to see it, includes the videos, the integrated exercises, the programming exercises, and access to the adaptive textbook. That includes Vocareum problems, that includes our adaptive textbook, both of which are supplied for free to free students. That was one of our early interesting experiences, was that we knew part of our mission was to make content more openly available. And very often that's easy for us as a university to say, but it's oftentimes more difficult to get partners to buy into that because they have to make money. But our early experience was that Vocareum and our other partners were all very passionate about, if students are getting something that you created for free, we're okay with them having our components for free as well, which we've always appreciated. There's also a verified MOOC, so if students pay some money for a certificate that they get to verify that they actually completed the course, they get the same material, as well as problem sets. Actually, that blue bar should go a little bit lower. Actually, I take that back. That's the next thing. There's also a certificate MOOC series, which is where they also get the problem sets. That breaks the MOOC into 4 mini courses, mostly because we found out that students are intimidated by signing up for a 16-week course, but aren't intimidated by signing up for 4 4-week courses, which is just interesting. So we broke it into a certificate MOOC series that gives a certificate and offers all the content, all the assessment that our Georgia Tech students get. And then we have our Georgia Tech course, which is everything else, plus the support of recitations and TAs. Recitations are like optional class meetings with teaching assistants who can deliver some additional instruction, things like that. The free MOOC opened back in February 2017, shortly after we opened Georgia Tech course, and then we split it into the 4 mini courses in July 2018, added in the proctored exams, things like that, and made it kind of a heavier certification. We've since then split it in other ways. We launched the free MOOC series in parallel with the certificate MOOC series, and for our Georgia Tech students, we've also used this as the honors CS1 course for our honors program, as well as for dual enrollment for Georgia Tech high school students in the state of Georgia who wanted to take a college course where their tuition is actually funded by the state. So the course was created with a number of different partners. Vocareum, as you see in the bottom right, is a platform for all the assignment exercises. edX is our MOOC partner for laying out the content. We've in the past used Proctored as our proctoring platform, and McGraw-Hill Education was our adaptive textbook platform. These pieces have all fit together with remarkable ease. The majority of our content at this point, though, in terms of where the intelligence and the assessment and the interaction of the course happens, is within Vocareum. We've gotten more modular about other things. Other things can be more easily shifted among platforms if necessary. But the Vocareum component is very heavily tied to some of the advantages of that platform that really are built with CS1 in mind in some places. And you'll see what I mean in a minute. As far as the structure of the course, the video content is about 20% headshot, where you have to look at me standing in front of a screen and babble about stuff, and 80% screen capture, where we show some code. If you'll watch carefully, you should see some pin markers around the code on the right, where I'm kind of talking through the code, highlighting things, drawing connections between certain lines of code and the output to help explain what it is. And there's a link at the bottom. If you ever want to see any of this, it's all available right now. If you click into the individual courses from that link at the bottom, you can enroll in them for free. You don't have to pay anything. That page is just the landing page for the certificate program. For the exercises, which are really what we're interested in here, we have our programming problems. There's an example shown on the left, as well as some multiple choice text and tree problems. They're just kind of little knowledge checks that typically follow immediately after videos. For the programming problems, if you start to use Vocareum, you'll find that they offer different options as far as how the IDE appears. Some are more full-featured, some are more stripped down. We go with the stripped down one. This one on the left, actually the colors are different now, but this one on the left, because we are a CS1 class, and yes, I can provide the slides later. Because we're a CS1 class, our goal is really to limit the friction with which students need, limit how much students need to learn about the infrastructure and the overall setup and all the options and things like that, and really get them interacting with code as quickly as possible. Our early chats with students and things like that showed that students would often get into the big IDE, the PyCharms, the Eclipses, and things like that, and they're just very intimidating if you're a novice coder. And so we wanted to go with something like this, which is just a very simple, here's your code, here's your output. You have 3 options: submit, run, and reset to go back to the start. And that's all you have to begin with. So it really gets you interacting directly with just the code itself, the way you might in a normal course within Idle or something like that, within something very simple and straightforward with a notepad. So that you're not jumping into it as if coding is like working in PowerPoint or something. You really understand it's about the code itself. The other thing that's important about this kind of setup is that you'll notice, because it's such a simple view, it really removes a lot of the stuff we don't really need at this level. It's easy to integrate within the course. And so this is actually a look at how coding exercises integrate into the course. A student scrolls down, they see a video, they watch the video, they scroll down, and immediately right there within the window is where the coding activity actually sits. So it's not a context shift. It's not download this file and go open PyCharm and then come back and upload something. It's nothing like that. It's right there in context of the course. And so it's a more guided and I think streamlined experience for students. This is what we've gotten, I think, the best feedback about is that they don't spend very much time thinking about where do I need to go right now? I watched all the lectures earlier. Now I'm going to go do my homework, things like that. It's all kind of a guided experience of we think right now you're ready to do this exercise. Right now you need to watch this video. And we've also had some unexpected feedback about this setup. One of my favorites was, well, I shouldn't say one, it's happened more than once now. Several students have reached out to us noting that this was the only CS course they could take. Because they were enrolling at their local library, or they were enrolling on an iPad or something like that, or a smartphone, and they couldn't install something like Python. They couldn't install a development environment. And the fact that everything you do in this course is in the browser was a huge selling point for them. Now, I can't imagine trying to write code on a smartphone, but it's been really interesting to hear that people in places that don't have access to a computer that they have administrative privileges on or anything like that are able to now take a course like this. So as others design CS courses, that's one thing I recommend keeping in mind. If you're going for an open audience, consider some of the overhead that has to go into interacting with your course. Do they need to be able to install their own software, things like that? Obviously, if they get into computer science as a career or anything like that, they'll need to then. But do you need to presuppose that? Or can you reach students where they are who might not have access to their own devices or anything like that? I should note that we use edX in this. And so what you're seeing right now is the edX visualization. As far as I know, something like this could very easily be done as well in a more standard learning management system. So we use Canvas for our other classes. And I haven't personally used Vocareum in Canvas, but I can easily see how it maps to it as a module that you'd have in Canvas, you would insert into a course flow. So don't think that what you're seeing here, this kind of integration, is something that's only restricted to edX. I think most learning management systems that you might use nowadays have some facility to create a course experience like this. So Sanjay mentioned in his intro that one thing they do is some random test cases, some random input, things like that to test code. We actually built something like that too. I should say that we built our infrastructure within Vocareum back in 2016 is when we were building a lot of it in 2017. And so I think at the time we manually built a lot of things that now are natively supported in the platform. So anything you see here, you might want to make sure there's not a better way to do it now, because we built a lot within the platform for our own use that probably is now more native as time has passed. But for example, you see here that on that previous problem, we give students a number of test cases to run their code against and just to test it for themselves. But we were concerned with overfitting. Our course is entirely auto-graded because that's what we have to do to achieve MOOC scale. Is that we, at MOOC scale, you can't hire more TAs as more students enroll in the course. And so everything has to be evaluated automatically. But that creates challenges both for integrity and for feedback. And this is one way we try to accomplish both of those. We were concerned about overfitting, that students would say, this is going to run it to 10 test cases. I know what the 10 test cases are. If test case 1, then here's the answer. If test case 2, here's the answer, things like that. So what we actually do is randomly generate some test cases. So students have some consistent look of, I always know it's going to be tested against -3.7, and I can check to see how it updates for that. But then there are other test cases I won't know in advance what they're going to test against. And so that gives some check for integrity, that students aren't just writing code that will pass the exercise without actually solving the problem. And it also provides a feedback opportunity, because by giving students this multitude of test cases, for one, it's authentic to what they do. If they go into CS as a career, you need to learn how to write test cases, and I think the best way to learn that is to see the value of having test cases in the first place. And it's also it's authentic in the sense, or it's feedback in the sense that we give them some guidance on how to interpret not just one wrong answer, but a system of wrong answers. So one example, and we actually have a problem very early in the course where students are basically asked to add 1 to a number and print the result, just to kind of understand how it works in general, or how code runs and stuff like that. And one of the pieces of feedback we give is go to your full results file, because if you find you're always off by the same number, then it tells you that your math is wrong. If you're always saying the same number, though, then it tells you that you're not looking at the right value. And what we find is that students very often will assume, well, I'm supposed to say 4 and I said 5, so I'm always off by 1. But then they go into this file and find out, actually, I'm just always saying 4 no matter what the input is. And that gives them some feedback on what's wrong. So Sanjay's right, of course. The everything you're seeing here is Vocareum embedded within edX. So when you see that external resource thing at the top, I don't know why I'm pointing at my screen, y'all can't see me. We see external resource at the top. That means something is embedded into edX from another site. And that actually, I'm actually glad you asked that, Judging, because that's been one of our interesting pieces of feedback we have to give every semester. Is we and my teaching assistants will talk about, go to Vocareum and do this. And sometimes we'll get strange looks from students like, what is Vocareum? Because it's embedded so seamlessly in the platform that students don't actually know that they're integrating with a third-party tool. I actually think y'all should put a logo somewhere here, just because they should know that this fantastic system is not native to edX, but it's this other great organization. I'll let Sanjay answer your question, Benny. So the other thing we supply are sample answers. This came from some early feedback we got from students that basically said, I know I solved this problem and I got the points, but I know there's got to be a better way. And so they wanted to know what that better way was. So what we built was basically a way to say, once you've solved the problem, not until you solve the problem, you can see an answer, how we would solve the problem. And so you can use that also as a feedback opportunity to compare what you did to what we would do on the same kind of problem. It's another kind of valuable implicit feedback opportunity, because by comparing your answer to our answer, you kind of see how it may have been simpler, how you may have been able to get them more efficiently. And I think the act of making that comparison, I think, is actually a valuable learning exercise as well, because it's not just teaching you, oh, I did this with 3 nested for loops and this really complicated method, and I could have done it real simple if I had used, a list or something like that. I don't know. But it's also the act of interpreting code and finding the commonalities and finding out how 2 segments of code do the same kind of thing that I think is a very valuable learning exercise as well. So we built that into our version of our auto-graded system as well. There's something else about the viewing sample answers, though. Oh, and the other thing is we actually also supply multiple sample answers. So if a problem can be solved in multiple ways, we'll say, here are the 3 or 4 different ways you can solve it. And so you can compare those as well and understand their strengths and weaknesses. The only thing I'm still struggling to figure this out. So if anyone has any thoughts on this, I'm all ears. The kinds of students who very often view the sample answers and thoughtfully step through the comparison are usually the kinds of students who don't really need to. The ones who really need to do this are the ones who are very often trying to move through the course more quickly. They want to get their points and get done. And I've struggled to try and find a way to encourage students to look at sample answers like this and draw more intelligent conclusions. For our Georgia Tech students, we have something called TA check-ins, which actually require students to meet one-on-one with one of our teaching assistants, walk through their code, explain how it works, and get human feedback on that. So that's one way we supply that. But it's difficult to integrate that throughout the course. Ideally, I'd like them to do that, once a week, but the capacity isn't there, and the scheduling would be a nightmare and things like that. So if anyone has any ideas on ways to encourage students to look at kind of things like this, please let me know. So one of the early things that was one of my requirements and has been one of my favorite features of this course is that everything you see with these exercises is also available on our time proctored tests. So Sanjay mentioned that in light of COVID, they've been doing more testing. We've been doing that actually for a while as well, and it integrated perfectly well, both thanks to the flexibility of edX, the flexibility of Vocareum, and the flexibility of our proctoring partners. But what that means is that when students get into a test, they're able to submit and run code live right there on the test. And get live feedback, and we give them unlimited attempts. My argument is basically, I believe learning to code is not about writing perfect code the first time. It's about writing imperfect code, testing it, using that output to revise it, going through that stepwise process of, let me write the first 2 lines, make sure those work. Okay, those work. Now I'm going to move on to the next part. That process is what I care about assessing. And I find that it's not how we usually assess computer science knowledge in traditional tests, through solely through technological restrictions. It's not that anyone thinks that handwriting code, actually, at least somebody might. I've never talked to anybody who thinks that handwriting code is the best way to assess computer science knowledge. But it's the way that we kind of have to do it in order to ensure integrity and to do everything else that we have to do to make sure that individual students are getting credit for the knowledge that they themselves have. Within this environment, we're able to actually give them a fully functioning IDE, let them run problems on the test, and get live feedback, which is fantastic. And they hear that usually, and they think, oh my gosh, that's awesome. I get to find out live on a test how I'm doing. And then they take a test and they say, that was great. I knew while I was taking the test that I was doing really well. And they get to one of the next tests, which is a bit harder, and they say, oh, this is awful. I know exactly how poorly I'm doing, which has been interesting too. There's a psychological component to this I think is really, it's worth researching, just the notion of live feedback on a test, live grades on a test, such that you know as you go through exactly how well you're doing. It can have an interesting relationship with testing anxiety and things like that. We try to front load our tests with some easier problems just to give everyone kind of a positive state of mind as they enter it. We try to specifically write our questions to delineate different levels of knowledge. So we have questions where we say, this question differentiates a D level knowledge from a C level knowledge. So it's a pretty simple question. If you can't do this question, then you don't have better than D level knowledge of the topic. If you can, you have probably at least C level knowledge. And so we try to put those in difficulty order so that students are moving through and getting some positive feedback as they go. It's also had the interesting effect that because students know exactly, so because everything in the course is auto-graded, students always know exactly how well they're doing, which is incredible. I think is really what education should be. There's not the delay around how long you have to wait to find out how you've done homework, and you've turned in 2 more homework since you turned in that first one, and now you found out you made a mistake on that first one that you haven't fixed in subsequent ones. So the fact that they always know exactly how well they're doing, thanks to these auto-grading features, I think is incredible. But it's also really weird because I still have, to this day, no idea how hard my final exams are, because everyone quits the final exam as soon as they get their next possible letter grade. And so every semester I look at the clustering of final grades, and I find that almost everyone in the class gets between a 90 and a 92, or between 80 and 82, between 70 and 72, things like that. And hi, Dante. Sorry, one of my former students is here. And it's funny because we know that they're basically just stopping the test when they get whatever the next possible letter grade is, so they can go off and study for their own finals. So the class average on my final exam is usually about a 60, but that's because everyone is just stopping whenever they get the grade they want. So it's interesting. There's a lot of things that go into this kind of setup that we know we're changing the way we very often teach, but there are ramifications of that we don't anticipate, like the idea of students picking and choosing where they want to earn their credit because they know exactly how well they're doing. I think that transparency is great, but it can create some problems, because if a student just really doesn't want to learn a particular topic, they might be able to do the math and figure out how they can get through the class without learning that topic. That's interesting. So I think these are all things to think about if you're going to be designing a course that uses more of these features. These are some of the things you'll encounter. For our total volume, now we have over 500 coding problems. I actually can't count because I can't get them to list in a way that lets me easily count them. But there's a ton of them. We built our own kind of auto-grading infrastructure within Vocareum that I think is now overkill, because I think a lot of those features are supplied natively. But what amazes me is that spinning up a new problem with the full auto-grading, with the random test cases, everything like that, the hardest part is thinking of the idea, honestly. Once I know what I want the problem to be, it takes 3 or 4 minutes to write the directions in a clear way. Writing the random test case generator takes 2 minutes. Writing the autograder is just, you supply a correct version of the problem, and it just compares students' output to your correct version. And so we're able to create new problems just on the fly really, really quickly. But they still have all these features around automated evaluation, things like that. So I think very often the hardest part of this is writing new problems, but with the platform working the way it does, we're able to spin up new ones extremely quickly, which lets us have a really large volume of practice for students to do. We, I might skip a slide later because I think I say this in that slide, but I'll go ahead and say it because it's pertinent now. We did a study to compare how students spend their time in this version of the class versus the traditional in-person version of the class, because we had observed the learning outcomes between the two versions were the same. We did a pre-test, post-test in two versions of the class, and we found that the learning gains were the same across the two versions, the online and the traditional version. But the online students were reporting spending significantly less time on the class, and we were trying to figure out how are they learning just as much in less time. And the reason, based on their self-reported time distribution, which granted is self-report, so it's I wouldn't say that students spend exactly that much time on these things, but in terms of the overall trends, students in the online version reported that about 75% of their time was spent coding, whereas in the traditional version, they spent about 40% of their time coding. So the actual time spent coding was actually higher in the online version, even though the overall amount of time spent was less, because they had the flexibility to skip videos, they had the flexibility to watch them at double speed, to only go back and see them when they need to. They know that, you know, the nature of the assessment is that they know how to prepare, and so they have less risk of over preparing and things like that. So it was an interesting finding to find that it was really getting them to the heart of practice a lot faster. And I don't think that's people have suggested that that's difference in teaching style, and I really don't think it is. I think it's difference in the affordance of the system, that when you have a system that allows you to spin up exercises very quickly that are automatically evaluated, I never have to worry about something like, do my TAs have time to grade this assignment? I can spin up 20 new problems tomorrow, and it doesn't create any more ongoing time on us. And so we're able to have a lot of flexibility to build a lot of practice opportunities without worrying about what it means for our workload. So I mentioned that we built our own engine within Vocareum because we knew we were going to do this kind of MOOC style approach. So we call it Phineas and Ferb because I'm a fan of the show, and I'm apparently 12 years old. But the Phineas is our global autograder, which receives students' code for any given exercise and does some processing on it, and then feeds it through to a local autograder that does the stuff specific to that problem, its own test cases, its own correct answer, then feeds the result back to Phineas and spits it out to the students. So then Phineas actually says, you passed the exercise, you got your points, here's your feedback, here's your results, or you didn't quite pass it, here's one of the things you got wrong. I might say something like, excuse me, we expected you to say 5, but your code said 6, or it might say something like, we said to do this without a for loop, but you used a for loop. So it can also check code in that way. Like I said, this is the way we did. I think this is now overkill because I think a lot of these things, yes, that's exact thing. Grace, you're exactly right. The inspiration for this was that the one that the students hear from is the extrovert from the show. So I think a lot of the features that we built in are now supplied more natively through Vocareum. We built this in part because we knew we were doing this kind of MOOC style approach that was going to involve a very, very large number of very small practice exercises. And so we wanted something that would create some consistency across them that was specific to us. At the same time, what's always been interesting to me about working with Vocareum is that I work with other platforms. edX is a good example of this, actually, that make what they want you to do very easy to do, but you can't do anything outside of that. And in the case of edX, it's actually a really nice feature because it automatically populates so much for you that there's very little manual work on how you do, how you set up a grade book. It's just automatically pulled from the structure of the assignments. But it can create a slight limitation because you're also forced into that structure. If you want to subdivide something or have problems in different places that account for the same assignment, you're not able to do that. So it means less work for you to do, but less flexibility in what you can do, which makes it a fantastic partner for Vocareum where you can do anything you want. Now, the more non-traditional what you want to do is, you might have to do some more work on it yourself, but you can do it. There's never been a single thing that we wanted to do in this platform that we couldn't find a way to do. So I think they're really nice to work with together if you're looking at doing something like a MOOC, just because they complement each other really well in that way. You have one that's very flexible and letting you do whatever you want, and one that's very streamlined in automatically organizing things based on the implicit structure of your course. To give you a timeline, we launched the course in 2017. This is a little outdated, but the bars all extend to the right. We're still running the honors program course as well as the free and certificate MOOC series. Our enrollment has been pretty much even to about 250 to 300 students for our Georgia Tech students over time. It gets about as many students as the traditional version of the class, with some interesting trends in majors. Computer science majors tend to actually not take the course in either version because they took AP computer science in high school. But then those who do usually take the traditional version because I think the assessment style in the traditional version is more similar to what they would see going forward. I show this graph mostly just to contrast with this graph. If you look at the bottom, the red from our enrollment of Georgia Tech 4-credit students is still down there, but it is absolutely dwarfed by the other enrollments. Now we know MOOC enrollments are very often very gaudy anyway. We've had 250,000 enrollments. A large number of those students never actually opened the front page, so it's not clear why they even signed up. So I usually find it more interesting to look at course completers, and this is the chart of that. Of the over 10,000 students who have completed the course, 1/5 of them have been our Georgia Tech 4-credit students. About 600 of them were back when edX would let you complete the course without being a verified student of any kind. We had about almost 700 students complete the course in that way. And back then as well, 200 students completed who paid for the verified certificate. Since we broke things out into the series, it's exploded. And so we've had 3,300 people complete the free MOOC series, as well as 5,500 complete the certificate series. And this data actually is a few weeks out of date. And I only know that because the spike in interest over the past 3 months has been incredible. My top 10 weeks for enrollments in the course have all been the past 10 weeks. So the interest in this, in light of everything that's going on, has been incredible. And it's been inspiring for me to see how modern technology lets us make something accessible and rapidly shift without nearly as much strain. It was interesting teaching in in spring. All my classes are online, so the transition to remote teaching in some ways was nothing for us because the class was already online, but there were transitions individuals were going through. And so we wanted to be extremely accommodating to say that, yes, this class was online anyway, but you're going through a lot. You might be moving. You might be, suddenly without access to the good the internet connection that you have on campus, things like that. And so what was more remarkable to us was that the online structure let us be so flexible, because everything being automatically graded, all the videos being pre-recorded. If I had a student who said, I need an extra month because I've moved home and I live in South Africa and we have rolling blackouts for 8 hours a day. That's actually one of my online master's students, but same kind of thing. It's trivial for us to say, sure, take another month. We don't have to marshal our grading resources to grade your work late. I don't have to figure out a way to get you a lecture that I've already delivered in person. Just the flexibility to just be able to tell students, let us know what you need and we can work with you has been amazing. I think the most positive feedback I've gotten has been on that flexibility, and people say it as if it's because I'm a nice person, and maybe I am a nice person, but it's really been more about the platform and the structure lets us be so flexible because it doesn't cost us anything. So we've done a lot of research on the course. So like I mentioned, students in the online CS 13-1, our pre and post test comparison have done as well or better than students in the traditional version on the same setup. The ones who specifically prefer the online course are very often the ones who have previously tried CS and either failed or quit. And so they take this version instead, maybe just to see something different. And they specifically have done better than some of the other groups have done. I think because of the emphasis on so much practice. CS is a skill rather than knowledge, and I think this way of teaching it lets us teach it as a skill. So that's been another thing we found. And they rate the online version as higher quality than other college courses they've taken. We asked them specifically, compared to the other courses you've taken, how does it rate? And almost all the ratings are either way better or a lot better than other college courses they've taken, a 6 or 7 on a 7-point Likert scale. And I think there's a lot of different reasons for that. I'd like to think maybe it's because I'm halfway decent at this, but I also think it's true that the platform, the automated evaluation, things like that, give really clear signals of effort and attention and care to students, that they see from the very first that a lot of work went into this, and so I can trust it to be a good presentation of the material. When I hit a problem, I can trust that it's going to be resolved somewhere, because there's so many tacit indicators of the effort that went into the development of the class. It's won some awards. It was rated last year as one of the top 100 rated courses on Class Central of all time. And we won the Bronze Award for Computing and IT at the 2019 Reimagine Education Awards, which bills itself as the Oscars of education, whatever that means. So that was nice. That's all I have to babble about. I don't know if there's anything else you had in mind specifically for me to talk about, Sanjay, that I can describe, because you know what we do in this course. If you want to see the course itself, there's the URL that gives the whole course in MOOC format. If you click into the individual courses, you can enroll for free. Excuse me. My lab URL is down there, where we post most of our research. And now that I have the URL up, I'm embarrassed at how out of date it is. But I think all our most recent research on this course is, no, I take that back. We have at least one paper that has been written on this that is not currently on the lab website. But whatever. And then if you want to see more about me, there's my my URL. Let me see real quick. Are the autograders open source? I'll show you the source. They're not currently available in any kind of repository, but I'm also not guarded about them. So I'd say they're open source, but they have to be manually transmitted. And they are heavily integrated into the Vocareum platform. They take advantage of some of the hooks that it has into things. I should mention this, actually. We have a new collaboration with a group called Sense Education. And they do code clustering for code. So, 500 students submit code, and they cluster it into 3 or 4 groups. So you can actually see, oh, here are the students who did it with a while loop. Here are the students who did it with a for loop. And we're working on something to allow that to then send feedback back to students to say, great job, you solved the problem, your solution works, but you did it with a, 2 nested for loops and all this stuff that's unnecessary. Try to do it in this way instead. So we can give some partial credit based on how well their, not just whether their code works, but how close it comes to what we consider one of the optimal solutions. So that's kind of exciting too. Another place where we can build some feedback opportunities into the structure to re-add some of what we lose by not having human grading. So, oh yeah, Q&A section. Let me go over there. I had the chat open, not the Q&A. All right. What's in the problem sets that is beyond the free MOOCs exercises? Mostly just more and harder. The exercises in chapters that are interspersed between the videos are usually very highly targeted. So we just did you just watched the video on for loops. We're going to do a very straightforward exercise on for loops, something like that. Then the ones in the problem set are very often slightly higher reasoning. They're things like, solve this problem. We're not going to tell you that this is a for loop problem. We're not going to tell you anything like that. But we're just going to tell you, write some code that accomplishes something. And so they're more difficult and more challenging that way. Moreover, there's just more of them. So it's meant to be, you do some practice throughout the course, and then you do the problem set as kind of a more summative assessment, as well as more practice at the end of the chapters. 500 coding problems. Oh, hey, Peter. 500 coding problems in total. How many each student get in one course? For the Georgia Tech students who take the entire course as one, and I know I've kind of hand-waved over some of the specific context about how we split things into 4 courses. I really view the certificate program that's 4 mini courses. It really is the course because it's all the content students get. So I refer to it as one course. For that, except for the test problems where the MOOC students get different problems from the Georgia Tech students, they all get all of them. Some of them are optional. Some are practice test problems you can do just for your own improvement. But I think that's a pretty small portion of them, maybe 50 or 60 or like that. Almost all of them are required. I kind of feel like as long as students are reporting that they spend less time on this version than the other version, we can make them do more, because more practice is always good. So generally speaking, except for the practice test problems, which are usually old test problems that we make available to you because why not? All students have all problems for them to do. How to avoid collusion for asynchronous assessment? That's a good question. I don't. I have actually, if you go to my my website, one of the papers we have from Learning with MOOCs a few years ago is called A Holistic Approach to Integrity in a CS1 MOOC, or something along those lines. I don't remember the exact title. But it basically says the way we preserve integrity in the course is by specifically subdividing the course content into the place that's for learning and the place that's for more systematic assessment. For the problem sets, for the exercises, for the videos, for everything like that, we tell students work together, talk to each other, do however much you want together. We know that online learning can be isolating, and we want to give you all the freedom in the world to break that isolation on your own. And so we don't check for it there. As a result, what we do is we calibrate our tests, which are proctored, no collaboration is allowed on the tests, things like that, such that they are an independently accurate rating of what you know. So tests are 50% of your grade in the class, and I actually calibrate the test so that an 80 on a test for me represents A-level knowledge, because I know even if you worked with your friends a whole lot on the exercises and the problem sets and everything like that, even if you basically copy code throughout that, you still need to get at least an 80 test average on all the tests to get an A in the class. And honestly, if you get that level on the tests, I believe that indicates you have A-level knowledge of the material. So it's really, I say it's holistic because it's basically saying, where are the areas that we are going to care about integrity, and where are the areas that we're going to be open for collaboration? And as long as the areas where we're really proactive about verifying integrity are enough to verify your overall knowledge, then we feel safe in allowing some more social learning to happen elsewhere. But I also think it's very important in that regard that students feel comfortable collaborating with one another, especially in an online class where otherwise they can feel even more isolated. So, Dante, 13.1 has provided a wealth of data regarding its impactful pedagogy. Have you been able to quantify the impact on the need for TAs? No, but just through lack of desire to. The course could be delivered with fewer TAs than we currently hire, but I'm a strong believer that the value in front-loading so much of this production is that we have more time to invest into working directly with students. And so we have a help, so my TAs, their responsibilities are almost all on the student support side. They run a help desk that students at pretty much any time during a normal waking hour can click into a Blue Jeans room right now, or they could go to a physical room in person and sit down with the TA and talk about their code, get help, things like that. The check-ins I mentioned before are one example of that as well, where we wanted to be more proactive in forcing all students to sit down and talk through their code with the TA to make sure they really understand what they're doing and things like that. I think that if we had to get by with fewer TAs, we could, but I think that the TAs for our on-campus course really improves the class experience. And it's also a great experience for the TAs themselves. I think that very often we view teaching assistants as, I don't have to tell you this, you were also a TA for me, as support for the course, but it's something for the person individually as well. It's also something that is a good experience, a good way to learn the material more. And so I think even if we can cut the number of TAs we can get by with, I don't think we want to, because it's great for them as well. It's a great way for them to learn more about CS, feel more comfortable with the material, give back, interact with others, everything like that. So yeah, we haven't tried to use it as a way of cutting that, which is nice. What is adaptive in the textbook? I don't think I can pull the textbook up quickly enough. If you're familiar with McGraw-Hill's SmartBook platform, it's effectively it's an interactive textbook that asks questions within the textbook, and then it re-highlights the course content, the textbook content, based on what you've already shown mastery of. So as you read through, it'll show you areas that you haven't yet answered questions on in red, areas that you've answered the questions on in green, so you kind of have an understanding of what you've already done, what you've already experienced. What's the difference between certificate MOOC series and verified MOOC populations? Largely semantic. It goes back to before we split the course into 4 subcourses, and but also before we added proctored exams. So certificate MOOC series is the one that's really meant to be almost identical to what students on campus do. It has the proctored test, it has everything like that. The verified was the lighter weight, you get the instructional material, you get the problems, and we give you a certificate for completing them, but there isn't the heavy verification of who you say you are, everything like that. Oh, these are actually in chronological order, that's good. I think I'm almost at the end. I wonder if you're able to host multiple choice questions on Vocareum in line with live instructions. I have no idea if you can do that. That'd probably be a question for Sanjay and them. I haven't done that, but I should say the setup of our class is kind of odd in the sense that we use probably 10% of what Vocareum can do, if even that, maybe 4 or 5% of what Vocareum can do. But the 4 or 5% we use with we beat it to death. We really use it very, very heavily. So we're using very few of the features of the platform, but the ones we use throughout the course, everything like that. For proctoring the online class, we've used Proctored for our Georgia Tech students. edX has an integration with, I think, Sci or Software Secure as well. I think they've added one for Proctored. So for the MOOC students, they use just whatever the edX one is at the time. For us, we've used Proctored in the past. Exam and test integrity. How do you establish that the person registered is the person taking the test? So the pattern that they go through is that at the beginning of the course, they do an onboarding test, which requires them to get on camera, hold up their identification, things like that. And then the subsequent test sessions are proctored, and it's checked to make sure they match that initial onboarding. Then those also use some AI and some human evaluation to check to see if they're ever talking to other people, if they're doing things that are suspicious, like looking down at the table a lot or anything like that. It's actually very easy to tell if someone's interacting with someone off camera, we found. So they check that, flag them, send them to us for review, and we choose which ones to act on. It's actually a great system in that way as well, because there's no he said, she said kind of thing. It's always, it's hard evidence. It's, here's a video of you Googling for loop syntax in the middle of the test, or here's a video of you asking your roommate to come over and help you. So that's how we verify that on that. So yeah, I think one of the interesting things in online is that there's greater risk for students to heavily leverage someone else to collaborate with. We actually had a town hall at Georgia Tech a few weeks ago about integrity. And one of the questions was how, in a remote environment, you ensure that people getting the credit are the people doing the work. And I think this is one of those, one solution for that. It's nice that it does the cross-exam checks as well. I think that's a really valuable part, because if you really wanted to go to the extreme and have someone else do your work for you, you have to find someone else who will do every single test in the class for you, in addition to faking an ID so they can pass as you or anything like that. And if you're in a program that has tests across multiple classes, it also compares across the different classes. So you have to find someone who would do that for every single class. So yeah, I'm happy to share the slides. I don't know about recording or anything like that. I don't know if we are being recorded. I think we are, yes, but I don't know what they...
David, we are recording, yeah.
Okay, yeah, I know what I have planned for that. I would love to see coding questions and demonstration of the interface with AutoGrader. Are more technical webinars available? I imagine you can talk to them. I don't know what they have planned, but I will also say you can see all of it live in action right now at that bit.ly link. So you can see exactly how it works, at least from the student perspective. So yeah, that's all available. So, and hey, it's noon, so that worked out well. So I don't know if there's anything else you wanted to talk about, Sanjay?
No, David, thank you so much. It has been very inspiring to work with you over the last few years in building this amazing course. And I think one of the numbers we are very proud of, I think from your course, we probably have like 40, 50,000 at least learners come to Vocareum and do at least one assignment. So it has been great to see how, the reach and the quality of the whole experience has been great. Thank you so much. And if does anyone in the audience have any questions before we wrap it up? And any last question? Of course, you can always contact us or I was going to offer you, David. I shouldn't do that, but you can always contact us at from our website if you have any questions, and we'll make the recording available. So, David, do you have anything, David Lane? That is there anything you want to add?
No. Thank you very much for joining us.
Yeah, thank you, everyone. So have a great day.
Yeah, thank you.
Thanks, David.